Imagine waking up one morning, reaching for your phone and discovering that all the ice on Earth has melted away. Every glacier, ice sheet, and snow drift simply gone. What would planet Earth look like? And more importantly, could this ever happen for real? I'm James Stewart, and you're watching Astrum Earth. Join me as we journey through a world without ice. What would happen to our planet? Which places would be most affected? And would anyone actually benefit from this worst-case scenario? Whilst this would mean misery for billions, there are always some who seek to profit. But first, let's address the giant, frozen elephant in the room. Why are we even talking about this? Historically, an ice-free world isn't as unusual as it sounds. We've been there before. For the past 12,000 years, we've been in an interglacial period. Yes, that technically means we're still in an ice age, which, given our rising temperatures and record-breaking summers, can be easy to forget. And it makes sense. Compared to previous ice ages, average temperatures are higher, and ice sheets are smaller. But in the interglacial period before this one, around 130,000 years ago, things were even warmer than they are today. Temperatures were 2 degrees above pre-industrial levels, and sea levels stood 6.6 to 9 meters higher than they are right now, mainly due to melt from the Greenland and West Antarctic ice sheets. But it's when we go even further back that things get really interesting. Today, Antarctica is Earth's biggest ice sheet. But if you were to stand on it 100 million years ago, there wouldn't be a snowflake in sight. Instead, you'd be in a dense subtropical forest, much like those now found on New Zealand's North Island. Sea levels at this time peaked at around 200 meters, the highest they have been in the last 540 million years. All over this ancient continent, plants thrived under the quite bizarre conditions of 24-hour sun in the summer, followed by 6 months of darkness in the winter. Antarctica was alive with more than just vegetation, too. Fossil records show that dinosaurs roamed the lands. It was home to 4-meter-long armored ankylosaurs, gigantic long-necked sauropods, and many more. This period, 100 to 66 million years ago, when the land dinosaurs all died out, is the last time we are certain the Earth was entirely ice-free. Clearly, today, things are very different. The once green terrain of Antarctica is now covered by an ice sheet, larger than the area of the USA and Mexico combined, measuring an incredible 4.9 kilometers at its thickest point, and holding around 60% of the Earth's total freshwater. Greenland chips in another 8 to 10%. The rest is made up of mountain glaciers, smaller caps, and finally, the cryosphere, all the other frozen parts of the planet, sea ice, snow cover, and the vast areas of frozen ground called permafrost. So, let's get into what happens if all of that vanishes. Perhaps the first thing that springs to mind is the rise in global sea levels, and just how big an impact that would have. At the time of the last dinosaurs, sea levels were a staggering 66 meters above what they are today, making them almost shoulder height with the Statue of Liberty. And if all the ice melted today, the same would happen again. The majority of that water, of course, comes from Antarctica, which alone would cause a 58-meter sea level rise globally if it melted. When you add in all the other ice on Earth, sea level rise gets to around 71 meters. And the world map gets a brutal redesign. Nearly every single coastline would be plunged beneath the waves, wiping out major cities everywhere. On the west coast of the United States, Los Angeles would be underwater, and San Francisco would become its own island. The East Coast wouldn't fare much better either. The entire states of Florida, New York, and even Washington, D.C. would vanish. In Europe, we'd lose the entirety of the Netherlands, all of Denmark, and nearly half of Belgium. The UK, where I currently live, would become an archipelago, and the city I call home, London, would be no more. And further east, the Black and Caspian Seas would connect for the first time in 5.5 million years, freeing up Kazakhstan, Uzbekistan, Turkmenistan, and Azerbaijan to be landlocked no more. Beijing, Shanghai, Seoul, and Tokyo would face new watery landscapes, and we'd lose the entire country of Bangladesh, 173 million people displaced in an instant. Only Africa would escape relatively unscathed in comparison, although Cairo and Alexandria in Egypt would become casualties, as would parts of Mauritania on the west coast. But sea level rise is only the beginning of the havoc ice melt would wreak, because arguably, something much worse would also happen. The idea of billions of people losing their homes, infrastructure, livelihoods, and potentially even their lives is simply horrifying. It makes the film, The Day After Tomorrow, feel quite tame by comparison. Whilst that's how melting ice would affect us, the planet itself would undergo something even more dramatic. The movement of Earth would be altered. Normally, as land ice melts, the mass of the water is moved from the poles to the ocean, where it's spread around the globe, essentially taking mass away from Earth's axis of rotation. This increases the Earth's moment of inertia, that is, its resistance to rotational acceleration. As a result, the planet slows, the same way an ice skater does when they extend their arms away from their torso to slow a spin. So, if the total mass of water stored in ice sheets and glaciers, more than 30 million gigatons, was redistributed, well, the planet would slow pretty significantly. But by how much? One calculation determined that if all the ice in Greenland alone melted, it would increase the length of a day by about 2 milliseconds. As Greenland's ice mass is about 1/10 of the total mass of land ice, and most of the world's ice is held at high latitudes, we can extrapolate that a total melt would increase the length of a day by at least several milliseconds. That may seem small and benign in our fast-paced world, but it's comparable to how much the moon slows down Earth over a century thanks to tidal friction. Although almost imperceptible to humans, technologies that rely on precise timekeeping, such as GPS, satellites, flights, and even space travel, would be sent into complete disarray. Speed of rotation isn't the only change. Shifts in mass cause the planet to wobble, moving the Earth's spin axis slightly from the imaginary line connecting the geographic North and South poles, in a process called polar motion. A slight shift in polar motion, or axial tilt, could trigger changes to climate, seasons, weather patterns, and even ocean currents, with effects ranging from subtle to dramatic depending on the degree and speed of the shift. Northern latitudes, for example, might see longer, hotter summers, while southern regions could get harsher winters. Ocean currents, such as the Gulf Stream or even the AMOC, driven by Earth's rotation, could veer off course. A slight tilt might disrupt the jet stream, leading to erratic storms. Think more hurricanes in unexpected spots or prolonged droughts. In short, these seemingly subtle changes would have huge ripple effects for those of us left here on Earth. And things don't stop there. Without massive ice sheets pushing down on Greenland and Antarctica, the land below starts a slow comeback in a process known as glacial isostatic adjustment. Imagine the Earth's crust like a squishy mattress under a heavy duvet. That gigaton weight presses it down, making the edges bulge out. Ice acts over thousands of years, turning the solid crust into something more like thick honey, viscous and flowy. So what happens when you remove the ice? The depressed spots bounce back up, while the bulgy edges sink. It's like your memory foam bed reshaping after you get up, but on a planetary scale. Normally, it takes millennia. In our hypothetical scenario, who knows? Amazingly, this process is actually happening as I speak. In Scandinavia, people noticed their shorelines shifting centuries ago. The ancient port of Östhammar in Sweden became landlocked by 1491, and so the whole town was moved as a result. In the 1700s, scientists carved sea level marks on rocks and tracked the changes. In the Gulf of Bothnia, sea levels were dropping 1.4 centimeters a year, but it varied at different points, proving it was the land rising unevenly. Why? During the last glacial maximum, about 21,000 years ago, huge ice sheets blanketed northern Europe and North America. As they melted, the squished land started popping back up, and so Scandinavia is still rising today. So, back to our ice melting scenario. The underlying continents which previously had ice on them would undergo post-glacial rebound on an enormous scale. Precisely how much the land would change shape and the impact this would have on local sea levels is not yet known. Calculations require greater understanding of the mantle beneath Greenland and Antarctica, as well as more exact dates of when the ice sheets first covered the land. What we do know is that sea levels would continue changing for a long time after all the water has reached the sea. In the shorter term, the immense ice loss would instantly reconfigure the Earth's gravitational field. This could amplify sea levels in the tropics, making a 66-meter sea level rise even more catastrophic for those living near the equator. Whichever way you look at it, it's not good news. But believe it or not, there are some people that might disagree. And I think one thing we can all agree on is we'd really like to make sure this does not come even vaguely close to happening. And the good news is, I have something you can do right now to help. Our friends at Planet Wild are a community-based nature protection organization. Think of them like crowdfunding, but for nature. The way it works is each month, their community funds a project to restore nature around the world, and then they document it with a YouTube video report. So you can see the impact of your contribution in real time. It's actually their transparency that inspired us to become members in the first place. I loved one of their recent missions, where they used a new piece of tech to help defend the last of Europe's ancient forests before they vanished. It was so cool. And you could help missions just like this right now. Give whatever amount you want, big or small, and you can cancel at any time. In fact, I love what they do so much I've actually got a special treat just for you. The first 100 people to sign up to Planet Wild using my code, Astrum11, will get their first month paid for by me. Yeah, right now, just scan the QR code on screen or click the link in the video description. And the best part? You'll immediately have an impact and see the results in less than 30 days, as we head back to the video. In a total glacial melt, uncovering Antarctica and Greenland would bring hidden worlds to the surface for the first time in millions of years. But we already know what they might look like. Over the last century, scientists have been mapping the bedrock below the ice sheets using satellite surveys, radar, seismic reflection, and gravity measurements. They've found that Antarctica is made up of sharp mountains and plunging valleys. It's home to the deepest land canyon on Earth, reaching depths of 3.5 kilometers below sea level. A 3D map of the continent also clearly shows the distinction between East and West Antarctica. The East is generally more elevated, while the West is a collection of mountainous islands. These are landscapes carved by rivers and 675 recorded subglacial lakes. The largest, Lake Vostok, is 250 kilometers long and about 4 kilometers underneath the ice. There are also hundreds of volcanoes. 138 have been identified in West Antarctica alone. Greenland, on the other hand, has been mapped much less extensively, but we do know it is shaped by mountains and has at least 60 relatively small subglacial lakes. So, would an exposed Greenland and Antarctica be barren? Or could humans actually find a way to live there successfully? Whilst we don't know for sure, what we do know is that both likely have things we need. and they lie deep beneath the surface. Rare earth minerals. Commercial mining in Antarctica was banned under the Antarctic Treaty, and as such, no extensive mineral reserves have been identified. But the continent is thought to be rich in minerals including coal and oil. Similarly, in Greenland, a 2023 survey showed it has 25 of the 34 minerals deemed critical raw materials by the European Commission, making it the 8th largest known reserve globally. Some have argued that this is why President Donald Trump has tried to purchase Greenland on more than one occasion. In a world without ice, could treaties be ripped up and a geopolitical land scramble take place to gain access to these resources? Well, based on our history so far, you wouldn't bet against it. In recent years, the Arctic Circle has become the central focus of a geopolitical conflict. As the ice caps sadly melt away, nations such as the United States, Russia, and China are rushing to assert ownership over the region's unclaimed territory. The Arctic sits at a critical point between North America and Eurasia, making it a powerful place from which to project military strength, and it also houses vast natural resources. A U.S. Geological Survey estimates that the region has 48 billion cubic meters of natural gas and various other fuels, equal to the entirety of Russia's oil reserves, and 3 times as much as in the United States. The Chinese government has dubbed the Arctic region as their Polar Silk Road, hinting at the trade routes they intend on pursuing following the acquisition of natural resources. The difference here is that China has no Arctic border, instead describing themselves as a near-Arctic state, even though its northernmost regional capital, Harbin, is on roughly the same latitude as Venice in Italy. As recently as 2024, the last piece of privately owned land in the Arctic archipelago, Svalbard, was up for sale for a cool $324 million, dubbed the Gates to the Arctic. In the end, the Norwegian government had to step in and call off the sale in order to prevent its acquisition by China, and not for the first time. Their attempts to buy seaports in Norway and Sweden, and even an airport in Greenland, have also been rebuffed. But it's not just countries that seek to benefit from the world melting away either. Niche money-making schemes from our thawing planet have sprung up all over the place. On a ship off Svalbard, entrepreneur Jamal Qureshi is literally picking up blocks of once Norwegian glacier ice from the ocean and bottling it. The ice is expensive and difficult to collect and purify, and production is difficult too, so limited to 13,000 bottles a year, and it's currently selling for $100 a bottle. In the Yakutia region of Russia, the permafrost is melting, and it's revealing 11,000-year-old mammoth remains. Demand for this ethical ivory has massively increased in China, and a tusk can fetch up to $100,000 on the black market. The people who collect these fossilized remains are known as tuskers. Carrying powerful firefighters' pumps on their backs, they carve out enormous 180 ft long tunnels under the frozen ground to extract the bones. The race for the Arctic is very much on, and shows that should our ice-free world ever become a reality, well, it could lead to some interesting geopolitics if Antarctica and Greenland go the same way. But this is purely theoretical, a ridiculous what-if that could never happen, right? Well, the short answer is no, certainly not in many of our lifetimes at least. The longer answer is that total ice melt is very, very unlikely. But we could get close, maybe a little too close. As we've seen, significant cryosphere loss has happened before, most recently in the last interglacial 130,000 years ago. We know this because there's evidence of sea levels being 6 to 9 meters higher than today, meaning a large melt of the Greenland and West Antarctic ice sheets must have occurred in the past. Global average temperatures in the last interglacial period were 2 degrees above pre-industrial levels, think some 1900 onwards, and we're already at 1.1 degrees higher now. This is down to human activities, principally greenhouse gas emissions. If our emissions continue at their current high level, the Intergovernmental Panel for Climate Change, IPCC, predicts an overall temperature increase between 3.3 and 5.7 degrees by 2100. Worryingly, the most recent IPCC report noted that sustaining the lower level of this warming between 2 and 3 degrees could eventually lead to an almost complete and irreversible loss of the Greenland and West Antarctic ice sheets. This would cause at least 13 meters of global sea level rise. However, they highlighted that evidence for this conclusion was limited. Other research has put a date to the complete melt of one of the ice sheets at the year 3000, producing a minimum of 7 meters of global sea level rise, assuming we don't rapidly clean up our act, that is. 1,000 years might feel far away in the scope of our lives, but in the usual time frames of climate change and indeed glaciology, this is incredibly fast. Even in the time frame of human history, this is unprecedented. Remember, we're technically still in an ice age and have had a relatively stable climate for the past 12,000 years. So, both Greenland and the West Antarctic ice sheet could melt under sustained warming conditions. But what about the much larger East Antarctic ice sheet? We don't think it has been ice-free in 66 million years, but there are big uncertainties under rapid global warming. With limited observations, our models of ice sheet processes and interactions with the ocean, atmosphere, and bedrock are incomplete. For instance, warm ocean water can melt the base of ice shelves, which accelerates the glacier's retreat. But as ice melts, the elastic rebound of bedrock causes local sea level to fall and can stabilize the ice shelves. At the moment, we don't know how much effect each has, and these gaps in knowledge around Antarctica are driving a lot of the current research. There isn't time in this video to also flesh out other impacts, like permafrost feedback and the slowing of the AMOC. But luckily, we have a full video on this if you'd like more information. There are a lot of small-scale processes that all play a part. Positive feedback mechanisms in the cryosphere. Think changes in albedo, greenhouse gas emission, and ocean heat circulation. All those things create positive feedback mechanisms that accelerate ice loss. This means that each level of melt can lead to ever more dramatic consequences. These non-linear responses to ice melt have to be accounted for in climate models to determine the full extent of the impacts, but at the moment, we're still working it out. So, what's the key to stopping all this and keeping this scenario hypothetical? Well, you already know the answer to this, I'm sure. Significantly reducing greenhouse gas emissions and slowing the temperature rise as soon as possible. As we come to the end of our journey around a very different-looking planet Earth, we've dared to stare into the darkest possible depths of our very existence. Countries would be lost, continents reshaped, and cities destroyed. Billions would suffer, and many more would cease to exist at all. Meanwhile, there are leaders, countries, and even individuals as you watch this currently preparing to profit from such eventualities. Some are even doing so already. To be honest with you, when I first started writing this video, an ice-free world felt almost novel, a silly, hypothetical game of chance. But the more I've peeled back the layers and seen what would actually happen, the closer this terrifying reality seems to get and more urgent the situation has become. Fortunately, there is still time to make a change, and make this hypothetical world just that,